Hello everyone! In this video we are going to talk about solving problems using ratio and proportion. So our goals in this video is I can solve problems using ratios, I can solve problems using proportion, and I know the difference between direct and indirect proportion. So ratios display the relationship between two or more things. So for example, in baking, we create recipes based on ratios. So things like you need, this much flour to this much sugar, this many eggs to this much flour, and so on, this much wet ingredients to this much dry ingredients. We also see it at gas stations where they display the price of gas per liter. Here in Canada, we do gas per liter. And so that is displaying that relationship so that as we're driving around and comparing gas stations, gas prices, we can compare them because they are a base or a unit ratio and they're compared per liter, right? So we know how much per liter, we can compare them and see which gas station has the cheaper gas for us. So anytime you are comparing two or more amounts, you can display that as a ratio. So some different ways that you may see this is using a colon, which represents the word two. So I may say in this example, 5 to 2. You can also use a fraction where you put 5 and then over 2, 5 to 2 like this. Or you can use words such as for every 5 Smarties, there are 2 red ones. Most often I like to use the colon because I find with the fraction, when you have one over the other, it's different than what we generally look at with fractions where the bottom number represents the total. And so sometimes that can confuse people when we're looking at fractions. So I prefer to use the colon when representing ratios. So just like with fractions, we always want to reduce our ratios to their simplest form. So let's practice that now. A gallon of liquid A weighs approximately 15 pounds. A gallon of another liquid weighs 25 pounds. Write this as a ratio in its simplest form. So first I'm going to write a ratio of liquid A to the other liquid. And I can write that as 15 to 25. Again, I'm using the colon as my way to represent this. And now I want to write this in its simplest form. And we do this using the same strategy or methodology as we do with fractions. So I'm looking for what number can go into both 15 or 25. I'm trying to find a common factor between 15 and 25. And I know that 5 can go into both. So I'm going to divide both numbers by 5. So 5 goes into 15 3 times, and 5 goes into 25 5 times. Then I'm going to look at the 3 and 5 and see if they have any common factors. And the only one they have in common is a 1, which isn't going to make us get these numbers any smaller. So I know I can stop there, and it's now in its simplest form. So I'd like you to try reducing these following ratios. You can pause the video and then start it up again when you're ready. So for that first one, we're looking at a common factor between 5 and 25, and we can reduce by 5. So I'm going to divide both by 5, and I get 1 to 5. For number 2, we have every 16 girls, there's 24 boys. So I'm going to write that as a ratio using a colon of 16 to 24. And then I'm looking at a common factor between 16 and 24, and there are a bunch of them. And so you may find a different factor than I do. For example, you can see that they can both be divided by 2. And if I do that, I get 8 to 12, and both 8 and 12 will have common factors as well. So it's okay if you don't get there in one step, as long as you keep going until the number gets as small as it can. And so you can actually divide 16 and 24 both by 8 in order to get 2 to 3. But if you don't see 8 right away, as long as you keep going and get down to 2 to 3, then that's okay. And lastly, question number 3, we have 18 to 54, and I can reduce that actually by 18. So I get 1 to 3. Okay, so I want you to reflect on ratios, on simplifying ratios and writing ratios, and we're going to use these now in order to solve proportion problems. So before we jump into the steps for solving proportion, I want you to see if you can get there by yourself. So I'm making a decoration using red, blue, and yellow tiles. In one bag, which happens to be 40 grams, so it's a 40-gram bag, you can find about 5 red, 6 blue, and 3 yellow tiles. And we're going to assume that each bag has about the same number of each color. And I want to know how many grams of tiles should I buy in order to get at least 100 of each color. So I want you to pause the video here, try this out on your own, and then start it up again when you're ready. There are a ton of ways that you could solve this problem, but I'm going to use ratios. Since we just were looking at ratios, let's see if we can use ratios in order to solve this problem out. So I know that I have a 40-gram bag is 3 yellow tiles, and I want to know, well, how many grams do I need to buy to get more than 100 yellow? Now, why did I pick out specifically yellow? Because there was red and blue tiles, but they had more than 3 in each one. So I know that in each bag, I'm going to get more than 3 red, more than 3 blue, and 3 yellow. And so if I know if I have at least 100 yellow, I'm going to have at least 100 blue and red. So that's why we're focusing just on the yellow color. But I need to figure out, well, how many grams for at least 100 yellow? So what do I need to multiply by here to get from 3 to 100, or at least 100? So I have my 40-gram bags and 3 yellow tiles in each bag. And if I multiply that by 34, assuming we need to buy whole bags and we can't buy, a part of a bag. So if I buy 34 bags, that means I'm going to get 102 yellow, which will get me over the 100 yellow I need, which equals out to 1,360 grams. So therefore, I would need to buy 34 bags or 1,360 grams of tile. So you can see how I've used ratios in order to figure out what number I need to multiply by to get to a number that's bigger than 100 yellow, and then I multiply this side by the same thing in order to get my final grams. Now let's try this one. So I have 2 gears on my bike. The smaller gear has 15 teeth. When we say teeth, we mean these little bits that stick out here. So it has 15 teeth and turns at 40 RPMs. How fast will the bigger gear with 25 teeth turn? I'm estimating it will need to spin at about 25 RPMs. Am I correct? And if I'm not correct, how much? How fast will it be turning to keep up? So pause the video here. Try it out and start it up again when you're ready. Okay, so if we apply the same logic we did with the last problem using ratios, I have 15 teeth and 40 RPM, and I want to know, well, how fast, how many RPMs is 25 teeth? So how do I get from 15 to 25? Because that will tell me how to get from 40 to the number I'm looking for. And so there's not really a whole number I can use here. So you can either find a fraction number that gets you there, or maybe I'm going to try and bring 15 down to 1. So I'm going to divide both by 15. So I get 1 teeth or tooth is 2.66666 RPMs. And then if I multiply that by 25, it will give me what 25 teeth are. And I got 66.67 RPM. So I'm saying, well, that's 25 is wrong. It should be 66.67 RPMs. But if we think about this logically, I have a small gear and a big gear. And the small gear is turning at a certain speed. Does it make more sense for the bigger gear to spin faster or slower? You can also think of this if you picture a tractor. A tractor has a small tire sometimes on the front and a big tire on the back. If the small tire is turning at 40 RPMs, it's turning a certain speed. is the big tire at the back going to be turning as fast as the small tire? Is it going to be faster? Is it going to be slower? And it's going to be turning slower because it's bigger, right? It doesn't need to turn as fast in order to cover as much ground. And that's the same with these gears. The bigger gear isn't going to have to turn as fast as the small gear in order to keep up. So it doesn't make sense that the number I've gotten is bigger. Right? Why, when I've used that logic, I haven't made a mistake in my calculations. So why would I follow this logic? It worked for the tile problem, but in this problem, that number just doesn't seem right. This is because there are different types of proportions. So let's back up a little bit. A proportion uses two or more equal ratios in order to solve a problem. So like you saw in these problems here, I used two different ratios. I had a ratio here and a ratio here where one piece was missing, and I'm trying to fill in that missing piece using the other pieces of information. So a proportion uses two or more equal ratios in order to solve a problem. So imagine you're baking cookies, you pull up a recipe for 5 people. What do I need then for 10 people? What do I need for 15 people? Trying to figure out how you adjust that recipe, that's a proportion problem. But there's two types of proportion. There's an indirect proportion and a direct proportion. So a direct proportion says that when one increases, the other also increases. So this is like the tile problem. The more tiles I buy, the more of each color I have. The more grams of tiles, the more of each color. Those are direct proportions. When one thing increases, the other also increases. But an indirect proportion says that when one increases, the other decreases. This is like the gear problem. The smaller gear will have to spin faster in order to keep up. So as the gear gets smaller, the speed gets bigger. Right? And so we have these two types of problems, and depending on what type of problem you have to adjust how you solve the problem. So because we solve the problems the same way, then we were getting an incorrect answer in our gear problem. So we have to solve those two problems slightly different. Otherwise, we get an answer where the smaller gear is moving slower than the bigger gear. Or in the tile problem, we would get that the more bags we bought, the less of each color we had. And so if you don't solve it properly or set the problem up properly, then you're going to get an incorrect answer for your proportions. So there is a certain setup that you can use that will help you with this. If you follow this setup, you will get the right answer regardless if it's a direct proportion or an indirect proportion. So the first thing is to set up your proportions. You're going to set up each side of your equal sign, each ratio, and then you need to check a couple things. You want the same units to be over top of each other. So as we saw in the previous questions, I had grams on one side and color, the number of color tiles on the other side. I had the number of teeth and then the speed on the other side. So you have to make sure that your units are the same. They're over top of each other. Then you want to make sure that the smaller number is on top. That is the key. If the smaller number is on top, you will get the correct answer regardless of it's direct or indirect. Once you have the question set up, you're going to cross multiply and then you end up dividing in order to get the letter by itself. So essentially you then just solve for the unknown. So let's try this out and see this as an example. So if 5 people can eat 2 pizzas, how many pizzas should I order for 20 people? So how I'm going to set up this proportion is I'm going to write the proportion as I read the question. So if 5 people can eat 2 pizzas, how many pizzas should I order for 20 people? So I have people on one side of my equation and pizzas on the other. And instead of writing it as our ratios with a colon, I'm going to write 2 pizzas equals 5 people, and then underneath x pizzas equals 20 people. Okay, so I've written them in fraction form. So 2 pizzas, 5 people, how many pizzas? 20 people. Now I need to check my 2 conditions. Do I have the same units on top of each other? Yes, I have pizzas on this side and people on this side. Check. The next one is the smaller number on top? Yes, 5 is smaller than 20. Now with our x, we have to think about our answer. What answer am I expecting? So if 5 people get 2 pizzas, is my answer going to be bigger or smaller than 2? I want my answer to be bigger than 2, so I'm going to put the x on the bottom. Depending on where you put that x will determine whether you get the correct answer or not, so you have to be very careful. So I'm thinking, do I want this number to be bigger or smaller than 2? I want it to be bigger. I have more people, so I'm going to need more pizzas, and so I'm going to put the x on the bottom. Now that I have it properly set up and I've checked for those 2 conditions, I can solve for x. To do that, I'm going to cross multiply, meaning I'm multiplying the 2 and 20 together and the 5 and x together. And I end up with 5x equals 40. Now I need to get the x by itself. And in order to do that, I have to undo or get rid of this multiply 5 I have here. To do that, I'm going to divide each side by 5. So 5x divided by 5 just gets me x. 40 divided by 5 is going to be 8. So therefore, you should order 8 pizzas. So I want you to try this one. If 4 coffees cost $4.50, how much would 10 coffees cost? I want you to write it out, try it, solve it, and then start the video again when you're ready. So our first step is to write out our proportions. So I have 4 coffees is $4.50. 10 coffees equals how much? Now I need to check my 2 conditions. I have coffees on one side, dollar on the other side, so that's good. And I need to check if my smaller number is on top. 4 is smaller than 10, so that's good. And my amount is going to be bigger because I'm ordering more coffee, so my x is going to be on the bottom. I'm now going to cross multiply and then divide by 4 to get the x by itself. And I get $11.25. It's very possible that you've set up your proportions slightly differently and still got the correct answer. So for example, you could have put dollars on this side and coffee on this side. That's okay. And because this is a direct proportion problem, so the more coffee, the more money, you have a little bit more flexibility with the setup. But if it's an indirect proportion problem and you've got the setup wrong, you're going to get the wrong answer. So even though it's slightly different, you can put dollars on this side, coffee on this side. Other than that, the numbers should be very similar to how I have it set up here. Okay, so if a 10-inch pulley turns at 50 RPM, how fast will a 2-inch pulley turn to keep up? This is one of our indirect proportion problem questions. So we need to make sure we have our proportions set up properly. So the first thing I'm going to do is write out the proportions as I read it in the question. So a 10-inch pulley equals 50 RPMs. A 2-inch pulley is how much? Now I need to check my 2 conditions. Okay, I have inches on this side, RPMs on this side, so that's good. Is my smaller number on top? Well, on this side it's not. I have a 2 on the bottom, so I need to flip these around. And here, am I expecting my 2-inch pulley to spin faster or slower? I'm expecting it to spin faster because it's smaller. It's going to need to spin faster to keep up. So my x is on the right side. I want my x on the bottom, but I need to put the 2 on the top. So I'm going to flip this around so that my 2 is on the top and my 50 is on the top here. So my 2 is on the top here, my x is on the bottom there. So I've only flipped the one side in order to make sure that my smaller number is on top. Now that I have it set up properly, the actual completion of the question is the same regardless of whether it's direct or indirect. I'm going to cross multiply, and I get 2x equals 50, and then I'm going to divide by 2, and I get 250 RPMs. With these types of problems, it can be really helpful to then read back over the question and see if your answer makes sense. So in this case, it is a 5 times smaller pulley. So the pulley, the 2-inch pulley, is 5 times smaller than the 10-inch pulley. So it's going to have to spin 5 times faster, and 50 times 5 is 250 RPMs. So it's another way to kind of think about it, but I always recommend going back to the question just to double check that your answer makes sense logically. Okay, you try this one, pause the video, start it up again when you're ready. Okay, a pump that discharges 5.5 gallons per minute can fill a tank in 10 hours. How long will it take a pump that discharges 15 gallons per minute to fill the same tank? So thinking about the answer I'm expecting, if it's able to put more gallons in the tank per minute, it should take less hours. So let's set up our proportions. Again, first, just how we read it in the question. So 5.5 gallons per minute is 10 hours. 15 gallons per minute is how many hours? Okay, so I have gallons per minute on this side, hours on this side, so I've got the right units. And now I need to make sure my smaller number is on top. On this side, 5.5 is smaller. But as we said, I want my x to be smaller than 10. So I'm going to flip that so my x is on top. So my 5.5 is smaller on this side, my x is going to be smaller on this side. Again, because I'm looking at the question, I'm anticipating what my answer will be. And I'm saying that, well, if it discharges more gallons per minute, it's going to take less time. So I want my number to be smaller. I'm going to cross multiply. So I get 15x equals 55. And then I'm going to divide by 15 in order to get the x by itself. And I end up with 3.7 hours. Okay, you try this one. Pause the video, start it up again when you're ready. An automatic spot welding machine can perform 5,000 welds per 8-hour day. How many hours will it take the machine to complete 3,000 welds? I'm going to set up the proportion as I read it. So 5,000 welds, 8 hours, 3,000 welds for x. And I'm checking my condition. I have welds on one side, hours on the other. 3,000 needs to go on top because it's smaller than 5,000. And if I have less welds, it's going to take less time. So I want my x on top as well. And now I'm going to cross multiply. And now I need to divide by 5,000 to get the x by itself. And I get 4.8 hours to weld 3,000 welds. Okay, so think back over the questions in this video. How are you doing in terms of solving problems using proportions? So you're even giving yourselves a thumbs up. I can solve the problems using proportions. A finger if you think I can sometimes do this, but maybe I need some more practice. And a thumbs down if you're thinking I'm having a lot of trouble with this, I need some more help.